Preparing for an information security engineering at Wells Fargo interview. You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like and share, and drop a topic request in the comments. Question 1. How would you implement zero trust architecture in a large financial institution like Wells Fargo? Zero trust means I do not assume trust based on network location. Every request is authenticated, authorized, and continuously evaluated. In a bank, I would apply it through strong identity, device posture, MFA, least privilege, microsegmentation, and detailed logging. I would start with critical systems and privileged access, then expand using policy enforcement points. The trade-off is operational friction, so success depends on automation and good exception handling. While answering, focus on identity-centric controls, MFA, device posture, least privilege, microsegmentation, continuous monitoring, phased rollout, exception handling, and balancing strong security with business usability. Question 2. How do you prioritize vulnerabilities when thousands are reported across enterprise assets? I prioritize vulnerabilities by business risk, not just CVSS score. I look at exploit availability, asset criticality, data sensitivity, internet exposure, threat intelligence, and whether compensating controls exist. A critical flaw on a public payment system gets handled before a higher-scored issue on an isolated lab server. I also define remediation SLAs, assign clear owners, and track exceptions. For leadership roles, the key is making vulnerability management measurable and accountable. Make sure to cover risk-based prioritization, CVSS limitations, exploitability, asset criticality, business impact, internet exposure, compensating controls, SLAs, ownership, dashboards, and coordination with engineering teams. Question 3. Describe your approach to handling a suspected data breach involving customer financial information. My first step is containment without destroying evidence. I would activate the incident response plan, preserve logs and affected systems, identify the scope, and involve legal, privacy, compliance, and business stakeholders early. For customer financial data, regulatory timelines matter, so facts must be accurate and documented. After containment, I would lead forensics, root cause analysis, eradication, recovery, and lessons learned. The goal is fast action, controlled communication, and durable remediation. In your answer, talk about incident triage, containment, evidence preservation, legal and regulatory notification, forensics, customer impact assessment, communication discipline, root cause analysis, and post-incident improvements. Question 4. How would you secure privileged access for administrators and production support teams? Privileged access is where I apply the strongest controls because one compromised admin account can become an enterprise incident. I would use a PAM platform with MFA, just-in-time elevation, approval workflows, session recording, and automatic credential rotation. Service accounts need ownership, vaulting, and non-interactive controls. I also define break glass access for outages, but monitor it heavily. For a bank, auditability is as important as protection, so every privileged action must be attributable. Be sure to mention PAM, just-in-time access, MFA, session recording, break glass procedures, approval workflows, segregation of duties, password rotation, service accounts, monitoring, and audit evidence. Question 5. What security controls would you expect in a cloud environment used for regulated banking workloads? For regulated cloud workloads, I start with a secure landing zone, strong IAM, network segmentation, centralized logging, encryption, key management, and policy guardrails. I would use least privilege roles, private connectivity, vulnerability scanning, secrets management, and continuous configuration monitoring through CSPM. Data classification drives encryption and residency decisions. The shared responsibility model must be clearly documented. Cloud can be secure, but only when controls are automated and deviations are quickly detected. While answering, cover shared responsibility, IAM, encryption, network segmentation, logging, CSPM, key management, workload protection, compliance mapping, guardrails, policy as code, and secure landing zones. Question 6. How do you design logging and monitoring to detect security threats in an enterprise environment? Effective monitoring starts with the right telemetry. I would collect identity logs, endpoint events, network flows, cloud audit logs, application logs, and privileged access activity into a SIEM. Then I build detections mapped to MITRE ATT&CK, enrich alerts with asset and user context, and tune false positives aggressively. High-fidelity alerts should create incident tickets automatically. Good logging is not about volume. It is about actionable signals, retention, and fast investigation. Make sure to cover log sources, SIEM use cases, detection engineering, correlation, alert tuning, MITRE ATT&AT mapping, false positive reduction, retention, enrichment, and incident response integration. Question 7. How would you assess and reduce third-party security risk for vendors handling bank data? I treat third-party risk based on the sensitivity of data and criticality of service. For high-risk vendors, I review SOC reports, security questionnaires, penetration test summaries, breach history, encryption practices, access controls, and business continuity capabilities. Contracts should include audit rights, breach notification timelines, data handling requirements, and subcontractor controls. I also prefer continuous monitoring over annual checklists. Vendor risk is not procurement paperwork. It is an extension of the bank's attack surface. In your answer, discuss vendor tiering, due diligence, SOC reports, contractual controls, data handling, access reviews, continuous monitoring, remediation tracking, exit planning, and regulatory expectations. Question 8. Explain how you would build a secure software development lifecycle for internal banking applications. A secure SDLC embeds security into engineering workflows instead of adding it at the end. I would start with threat modeling for high-risk applications, secure coding standards, and developer training. In CI/CD, I would include SAST, SCA, secret scanning, container scanning, and targeted DAST before release. Findings need severity-based gates and practical remediation guidance. For banking apps, I also emphasize audit trails, data protection, and post-deployment monitoring. Be sure to mention threat modeling, secure coding standards, SAST, DAST, SCA, secret scanning, security gates, developer training, CI/CD integration, risk exceptions, and production monitoring. Question 9. How would you handle a disagreement with an application team that wants to defer remediation of a critical security finding? I would first understand their constraint, release deadline, technical complexity, or service risk. Then I would translate the finding into business impact, such as fraud exposure, regulatory risk, or customer data compromise. If immediate remediation is not feasible, I would evaluate compensating controls and require a time-bound exception approved by the right risk owner. My style is collaborative but firm. Security leaders should enable delivery, not silently accept unmanaged risk. While answering, focus on leadership, risk communication, business impact, compensating controls, exception process, escalation path, collaboration, documentation, and balancing delivery pressure with security obligations. Question 10. What is your approach to encryption and key management for sensitive financial data? Encryption is only as strong as key management. For sensitive financial data, I would require TLS in transit, strong encryption at rest, and tokenization where applications do not need raw values. Keys should be stored in HSMs or managed KMS, rotated on policy, and separated from data access. Administrative access must be logged and limited. In regulated environments, I also map controls to PCI, privacy, and internal data classification requirements. Make sure to cover encryption at rest and in transit, tokenization, HSMs, KMS, key rotation, access separation, lifecycle management, PCI considerations, data classification, and auditability. Question 11. How would you investigate a phishing campaign that bypassed email security controls? I would treat phishing as both a technical and human-centered incident. First, I analyze the email headers, URLs, attachments, sender infrastructure, and delivery scope. Then I search mailboxes, remove messages, block indicators, and check whether users clicked or submitted credentials. If credentials were exposed, I force resets and review suspicious logins. Finally, I update detections and use the campaign to improve awareness training. The best response reduces both immediate risk and repeatability. In your answer, discuss triage, mailbox search, URL and attachment analysis, user reporting, credential compromise checks, containment, detection updates, awareness feedback, and metrics for improvement. Question 12. How do you secure APIs used by mobile and web banking applications? Banking APIs need strong identity, precise authorization, and abuse protection. I would use OAuth or OpenID Connect, short-lived tokens, mutual TLS where appropriate, and object-level authorization checks on every request. An API gateway can enforce rate limits, schema validation, logging, and threat protections. I also look for OWASP API risks like broken authorization and excessive data exposure. For mobile banking, security must pair with fraud detection and behavioral monitoring. Be sure to cover authentication, authorization, OAuth, rate limiting, input validation, schema validation, API gateways, logging, threat modeling, token security, fraud signals, and OWASP API risks. Question 13. Describe how you would run a security architecture review for a new payment processing platform. I would begin by mapping data flows, trust boundaries, actors, dependencies, and sensitive data stores. Then I would threat model the platform around payment fraud, credential abuse, data leakage, service disruption, and privilege escalation. Controls should include strong authentication, segmentation, encryption, secure APIs, logging, fraud monitoring, and resilience. I would document risks, required controls, and accepted exceptions. A good review helps architects make better decisions before expensive implementation mistakes happen. While answering, focus on threat modeling, data flows, trust boundaries, authentication, authorization, encryption, network design, compliance, resilience, logging, fraud controls, and architecture decision documentation. Question 14. How do you measure the effectiveness of an enterprise security program? I avoid vanity metrics like total alerts or total vulnerabilities alone. I measure outcomes, mean time to detect, mean time to respond, patch SLA compliance, privileged access coverage, control exceptions, phishing failure trends, and reduction in high-risk findings. I also track audit issues and recurring root causes. For executives, I translate metrics into risk posture and business impact. The best metrics drive decisions, funding, and accountability. Make sure to discuss outcome-based metrics, control coverage, mean time to detect and respond, patch SLA compliance, phishing resilience, audit findings, risk reduction, KRIs, and executive reporting. Question 15. What would you do if a critical production system cannot be patched immediately due to business constraints? If patching is delayed, I do not simply accept the risk. I validate exploitability, exposure, asset criticality, and available mitigations. Depending on the issue, I might apply WAF rules, restrict network access, disable vulnerable features, increase monitoring, or isolate the system. Then I document a time-bound exception with business owner approval and a firm remediation date. Temporary controls are useful, but they should never become a permanent substitute for patching. In your answer, cover risk assessment, compensating controls, exploitability, isolation, WAF rules, monitoring, temporary mitigations, exception approval, deadline tracking, and communication with business stakeholders. Question 16. How would you approach security governance for multiple teams building and operating different platforms? At enterprise scale, security governance must be consistent but not bureaucratic. I would define baseline controls, clear ownership, exception processes, and measurable standards across teams. Security champions help embed practices locally, while centralized teams provide architecture review, tooling, and risk oversight. I like policy as code where possible because it enforces standards automatically. Governance works best when teams know what good looks like and can prove compliance without manual meetings. Be sure to mention control standards, federated ownership, risk acceptance, security champions, policy as code, reporting cadence, architecture reviews, exceptions, training, and avoiding bottlenecks. Question 17. How do you detect and respond to insider threats in a regulated banking environment? Insider threat detection combines preventive controls and careful monitoring. I would enforce least privilege, segregation of duties, periodic access reviews, DLP, and strong controls around privileged users. Detection can use behavioral analytics, unusual data downloads, abnormal access times, and access to unrelated customer records. In a bank, privacy and employment rules matter, so investigations must involve HR, legal, and compliance. The goal is evidence-based response, not suspicion-driven surveillance. While answering, focus on behavioral analytics, least privilege, data loss prevention, access reviews, segregation of duties, monitoring privileged users, privacy considerations, investigations, HR legal coordination, and evidence handling. Question 18. How would you secure containerized workloads and Kubernetes environments? Kubernetes security starts before runtime. I would scan images, verify trusted registries, check dependencies, and enforce admission controls for approved configurations. In the cluster, I would use RBAC, network policies, secrets management, pod security standards, and least privilege service accounts. Runtime detection and centralized logs help spot abnormal behavior. I also harden the control plane and restrict admin access. Containers move fast, so automated guardrails are more reliable than manual reviews. Make sure to cover image scanning, admission controls, RBAC, secrets management, network policies, runtime detection, least privilege, pod security, supply chain security, logging, and cluster hardening. Question 19. Tell me about a time you led a security initiative across teams with competing priorities. I would structure the story around risk, influence, and measurable impact. For example, I led a secrets management initiative where teams stored credentials in code and deployment files. I aligned engineering leads by showing incident scenarios and audit exposure, then provided migration patterns, CI checks, and office hours. We prioritized critical apps first and tracked adoption weekly. The lesson was that security programs succeed when they reduce risk and make the secure path easier. In your answer, use a STAR structure. Show leadership without authority, stakeholder alignment, risk-based prioritization, measurable outcomes, communication, conflict handling, and how you sustained adoption. Question 20. Why are you interested in a lead information security engineer role at Wells Fargo? I am interested because banking security has real customer impact and operates at serious scale. A lead role lets me combine hands-on engineering with risk leadership, improving controls, guiding teams, and protecting systems that people depend on daily. Wells Fargo also has the complexity I enjoy, including legacy modernization, cloud adoption, regulatory expectations, and high availability requirements. I would bring a practical mindset, secure the business, partner with engineers, and make risk visible. Be sure to connect your motivation to financial services security, customer trust, scale, risk management, leadership, regulatory complexity, modernization, collaboration, and the impact of protecting critical banking systems. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.